Alright, part 3. Respiratory acidosis, started on that. The CO2 generation outpacing the rate of CO2 elimination. This is going to shift the bicarb buffer system toward generating more carbonic acid. You're in acidosis, which remember I said was related to hydrogen ion, but the bicarb is associated more with a base or alkalotic state. So if the bicarb buffer system generates more carbonic acid, then what's going to happen? It's going to dissociate into hydrogen ions and bicarb. And if this goes in reverse, starting at carbonic acid, then it's going to dissociate into CO2 and water. The water will go into the system. The CO2 will be breathed out into breathed out from the lungs. So the bicarb goes into a bicarb reserve. The hydrogen ion has to be neutralized. The buffer systems come into play. Respiratory will increase the respiratory rate to blow off CO2. The renal system will secrete more hydrogen ion, absorb more bicarb, and the protein buffer system will bind free hydrogen. In this figure, you see the events in respiratory acidosis. When you have an increased CO2, okay, then that kicks into this equation. CO2 will bind with water, producing carbonic acid, dissociate a hydrogen ion and bicarb ion. As these are released, the excess bicarb becomes part of the bicarb reserve. Okay, the bicarb reserve is here, so the bicarb can join with the sodium to form sodium bicarb. Now the excess hydrogen ion, so it either has to be tied up by other buffer systems or excreted at the kidneys. Notice though here at this last statement, the underlying problem, however, cannot be eliminated without an increase in the respiratory rate. Figure 24.8 shows starting with a normal acid-base balance, hypoventilation causes increased PCO2. That results in a fall in plasma pH. The response is stimulation of arterial and CSF chemoreceptors result in an increased respiratory rate. Kidneys will secrete more hydrogen ion and generate more bicarb ion. Buffer systems will come into play. And this will decrease the PCO2, decrease the hydrogen ion amount, and increase the bicarb amount, thus restoring homeostasis. Respiratory alkalosis, when CO2 elimination is more than CO2 generation. This shifts the bicarb buffer system toward generating more carbonic acid. The hydrogen ion will be removed as CO2 is exhaled and water is formed. Buffer system responses, same three: respiratory, decreasing respiratory rate; renal, secreting bicarb and reabsorbing hydrogen ion; and protein system will release the free hydrogen ions. And you can look at this figure 24.8 and 24, both of these figures, to get a better idea of how that's done. And that's it. End of chapter 24. Thank you.